boys and girls, our second week of online learning. Right, this week is all about density. We learn how to calculate density, okay? And then we're going to learn how you can use, by measuring certain things, experiments, how to actually calculate it. But today we're just going to learn how to calculate with numbers, okay? But first of all, what is actually density? What does density mean? Okay, now I think one way of looking at it is imagining these are taxis, by the way. Sorry, my drawing abilities is not the best. Okay, so imagine these two taxis. Okay, this is a taxi as it usually is. You can see lots of people in, and this is a taxi in our day, in Corona days. Okay, no more than 7 people in taxi. Okay, not many people. Okay. Density is how many, in this example, how many people are in a taxi. If there's a lot of people in the taxi, the same size, the size of the taxi is the same, okay? Dense taxi means there's more people in a taxi, okay? Density doesn't mean bigger or more mass. Density is to do with mass and size. Or what I'm going to use now, the word is volume, okay? The more mass there is in a certain volume, the more dense an object is, okay? But we need to go further. We need to be able to calculate it. So we're looking for a certain equation, okay? So we're going to write down density is equal to what? And let's try and think about it together. We said already it's to do with mass, okay? Like weight. It's not weight, but it's mass, how much stuff there is in there. And it's also to do with size, okay? What I want to say, the word I want to use is volume, okay? So if I know it's to do with them, and it's 1 divided by the other, what should we have at the top? Should we have the mass or the volume, okay? Remember, we understand that the dense material has more mass per volume. In other words, if I increase the mass, the density increases. So the mass has to be on top, and the volume has to be at the bottom. And let's just think about it for a second, okay? If I increase the mass, I'm increasing the numerator, okay, then the density will increase as well. But if I'm increasing the volume, let's say I'm taking the volume of the taxi and turn it into a bus. I'm increasing the volume. Let's say I keep the same number of people, then the volume is bigger. Okay? The mass didn't change. If the denominator goes up, that means the density goes down. The same people are in the bus or in the taxi. The taxi is more dense. Okay? Now, a word about unit. A few words about unit. Mass we usually measure in, correct, kilogram. You can measure it also in gram, you can measure it kilogram, but these are the units we work with. Volume, okay, again, there's a bunch of units we can work with. We can work with meter cube, we can work with centimeter cube, we can work with millimeter cube, we can work in kilometer cube. But I want to show you how you figure out what's the unit of density. Okay? Every quantity in physics has a unit. So density, if I work with kilogram and meter cube, then the units of density will be kilogram per meter cube. If I work with gram and centimeter cube, then the unit of density will be gram per centimeter cube. Okay? Now, you know, in equation, I usually like to write letters. So density, I will use the letter D, which makes sense, D for density. M for mass, and V for volume. Okay? I'm going to pause now. I'm going to stop this little video, and I'm going to send you another video where we solve a few examples. See you in a bit.